Today we start 3 lessons where we're going to look at techniques for graphing quadratic functions. Now these are also called parabolas. You've probably seen them before. They've got that classic U shape or horseshoe shape. They sort of look like this, or they can be upside down. They can be on the side as well, but we won't be looking at those ones just yet because they're not actually functions. And the reason we can tell they're not functions is because they would fail that vertical line test that we've already seen. But the biggest thing that people don't quite understand, perhaps when they start year 11, and I want to make this really clear, is that there's a big difference between a quadratic function and a quadratic equation. This function seems to have an equation. It's an equation for the curve. But technically we call this one a quadratic function because it's got y's and x's in it. And it needs to have both of those if we're going to graph it on a Cartesian plane that's got a y-axis and an x-axis. So this makes sense as a quadratic function. It has to have the y there. And then you'll have seen this before, the a and the b and the c are just constants. So they're just numbers. But the main reason that you can spot one of these things is it's got x squared in it. It may or may not also have some x's, and it may or may not also have some other numbers. Whether it does or not doesn't change its ability to be called a quadratic function. Mostly it just needs to have the x squared part and the y part. Now, how is this different from a quadratic equation? Well, a quadratic equation doesn't actually have any y in it at all. So it's all the exact same parts, but it's all equal to 0. Now, those can be written a variety of different ways. You could write something like 2x squared plus 5x equals 9. But if we subtract 9 from both sides and put everything on the one side, this is the way that we're used to recognizing them. This is also the way that we need to write them if we're going to solve them. So this one can be actually solved for x. And we've seen before that there can be 0 solutions, 1 solution, or 2 solutions to these when we're solving them. And we've got 3 methods for solving. We can sometimes factorize them, other times we can't. If we can't factorize, we can complete the square or we can use the formula. So that's something we've already seen in chapter 1, and these are skills that you should already have before you begin this lesson. Alright, so how do we go about graphing a quadratic function, one of these ones that's got the y in it? Well, there's 5 basic things to consider. Which way up is it is a great question to ask yourself first. Is it an upright one or an upside down one? Now, what will give it away is this number here, the a. In other words, the coefficient of x squared. So always have a look at what that is. And if it's greater than 0, or if it's a positive number, you've got an upright parabola. And if it's a negative number, then you've got an upside down one. We've also seen that if this number here is 1, in which case we've just got x squared, we call that a monic quadratic equation. And that can also be a monic quadratic function. If the number that's there is 1, they're much easier to factorize, aren't they? Whereas if the number that's there is not 1, we say it's a non-monic, and we have to be a little bit more careful when we're attempting to factorize it. So first, ask yourself which way up is it. So you've got an idea in your head which type you're dealing with. Next, easiest thing to do is to work out the y-intercept. Now, every single quadratic function will cross the y-axis somewhere. How do we know? Well, we've already looked at how to find the domain of a function. If we look for any restrictions in here, anything that x maybe can't be, there's actually nothing, because you can take any number, say let x be this or that, you can square it and then add some more of it and then add or subtract some numbers, and you'll get an answer. So there's no restrictions on x. That means every single x value that's possible will be able to be graphed with this quadratic function. And if we're graphing every single x value from infinity to negative infinity, then at some point it's going to cross the y-axis, isn't it? So how do we find y-intercepts? We should know this by now. We let x equal 0 and then we solve it. Now, I think you can see straight away here that if we let x be 0, this whole first term will be 0, the second term will be 0, and we'll be left with y equals, and we can put in there, y equals c. Oh, it looks a little bit like a G. I think you can see what I've done there. All right, what about x-intercepts? Well, just as you can solve a quadratic equation and get 0, 1, or 2 answers or solutions, you can find that there might be 0, 1, or 2 x-intercepts. Why is this? Well, when you're looking for x-intercepts, the method to do it is to say, let's let y equal 0, and we'll solve for x. Now, can you see that if you let the y be 0, let's let it be 0, now we've actually got a quadratic equation. And that's how these two are linked. When you're graphing a quadratic function and you're trying to find the x-intercepts, You let y equal 0, and now you've got a quadratic equation to solve, and you can solve it with any of these three methods. Now, it makes sense then that there could be 0, 1, or 2 intercepts if you just imagine different types of parabolas and what they might look like. So we could have a parabola, an upright one, that sits something like this, and you can see that it's going to go through the x-axis twice. Another parabola that's upright might just come down and touch the x-axis once, so there'll only be one intercept. And another upright parabola might sit what I think of as sort of above ground and not cut through the x-axis at all. And so thinking that through is really helpful, so that when you're looking for your x-intercepts, if you don't find any, don't freak out, perhaps there aren't any. So I've written here, are there any? There could be 0, 1, or 2. Let y equal 0, solve for x using one of these methods. Now today we're focusing on this method, and the reason we've got 3 lessons to graph out quadratic functions is to give us a chance to practice each of these methods and use them in slightly different ways. Now, once you've got your x and y intercepts and you know which way up your parabola goes, you're pretty well there. You can graph it and get a pretty good idea of what it looks like. But to finish off and be extra particular, it'd be really nice to find the axis of symmetry and the vertex. Now, it makes sense to me that if your parabola has symmetry left and right, then if you've found your intercepts, your x-intercepts, then your axis of symmetry is going to be exactly halfway between your x-intercepts. So it's going to be just a matter of finding what's the middle of that. So you can do that by finding the midpoint of your x-intercepts. In another lesson, we'll also look at a little formula that can help you. Now, why would you need some other method if we've already got one? Well, what if there are no x-intercepts? So we need another workaround. We'll be looking at that one another lesson, not today, but you can jot it down here in this list if you like, so that you've got a nice comprehensive list. And then once you've found the axis of symmetry, you can say, all right, I know the x value of my vertex. Your vertex is just your turning point. What's the y value? Well, you can say when x is this, y is, and just sub in. So I've written here, you can sub your axis of symmetry into your function. You can also complete the square to get your parabola in what I call vertex form, and that will be a whole lesson. That's why we're taking 3 lessons to focus on each of these 3 methods.